Now that we've run a problem, let's look at the output in ParaView very quickly. I think you'll get more out of it if you look at ParaView itself on your own. So here's ParaView. It's pretty easy. You just open up a file. For our HDF5 files, you open up the corresponding .xmf file. If you try and here, I'll show you what happens when we try and open up an HDF5 file. It'll say, I don't know how to deal with this HDF5 file. So hit cancel, open up the XMF file. So step 07, this is the, and it'll read the HDF5 file because of all the information in that XMF file. So you'll notice here I can turn on and off which values are read from the XMF file. I can select which time steps I want read in. Up here in the upper left, I select the field that I want to visualize. So I visualize the displacement field. Here's Y displacement. I'm at time step 0. I advance forward all the way to the end using this fast forward little sort of VCR type icon. Rescale to the data range. Here's where I'm getting the displacement magnitude. Let's look at the Y displacement. So here you can see I'm going to have a dislocation across the fault. Here's the warp by vector. So this is going to warp things according to the displacements. Scale factor by a factor of 200. Remember, I'm at my final time step. So there's my offset occurring in the domain. Let's rewind it. So go back to the first frame. And then so you can see as I slowly advance, we're going to have creep down here at the bottom. We're locked up above that. You can start to see the constant velocity boundary conditions. Then here, there I had my earthquake. So the upper crust caught up with the lower crust. Continue to have creep and velocity boundary conditions. There's my second event. So now my upper crust is caught up the lower crust. And again, advance forward, third earthquake. And then shortly after that, we stop the simulation. So we have a little bit of creep there at the bottom, and then we haven't caught up. We can bring in the fault information. So let's delete the volume. We're going to run over probably about 10 minutes here. Let's bring in the ground surface. So displacements and velocities. Where's that fault? That's enough file. I seem to have changed my seem to have lost my ability to rotate here. Somehow accidentally mapped my it's going to make it a little harder here. Oh, I apologize. There we go. Somehow I had this little thing here clicked on 2D. So learn something new every day with ParaView. So here we go. We're going to have displacements on the ground surface. Let's again do Y on the faults. Here, let's plot the fault slip. Plot the X component. This is going to be the lateral component now. Then we fast forward to the end to get things sort of scaled right. So I'll show some vectors here. So I'll move the slip over here to the left-hand side just by dragging and dropping. Let's warp the ground surface again by a factor. Let's just do a factor of 50 this time. So here's my ground surface. We'll look at the fault slip. Let's rewind it. So here you're going to see, so I need to, you'll notice my fault slip is going from 12 to 14. I better rescale that. So we better go to our faults, click on our edit color map, click on undo the automatic rescale. Let's scale the range from 0 to 14. Why didn't we get that? So there we go, 0 to 14. It did not reset my color bar. There it is. Now my color bar has been updated. So I can advance forward. You'll notice the bottom of the fault is starting to change color a little bit. As we keep advancing forward, you'll see there's our ground surface starting to catch up. And if I play this as a movie, you'll see it moving. So we had a question, how do I display displacement vectors? So that's this little globe glyph picture icon here that's to the left from the warp. So if I click on my ground surface, I can click on my glyphs, come down here, put in and edit. Let's do, what did I say, 50? So there you can see I've added my glyphs for the displacement field. I'll back up to the very beginning, and I'll play the movie again. See the displacement. I better do it step by step so that it shows up there in the back of that reader. We advance. You can start to fairly see, I zoom in, you can start to see the displacement vectors showing up. They're pointing from the original location to the deformed location. So they'll jump when the fault slips. And so that gives you an idea of pair view. Things to look out for are over here in properties, you can delete things that are already there. If you want just sort of basic information of what values and sort of are in there in their range, you can click on the information. You see sort of the type of mesh, number of cells, number of points. You can sort of, down here, velocity, you can see the range of the values. I can scroll this over, and I can see my X range is going from 10 to minus 10. Obviously, that's very small. My velocities in this case tend to be very small, but the displacements are big because I have large time steps. These are in meters per second. So in the output, even though things are coming in things like centimeters per second, everything in the output is going to be in SI units. So it'll be meters per second. So I think that we should wrap things up. Are there any other questions? So the question is, can you specify a user-specified time step for output, just like the user in the sort of the simulation time-dependent problem? So you can specify in pilots. We don't for the output. We don't have things like an output at time 0, time 15, time 10. There's two options. One is to specify, I want every single time step, or I want every other time step. And so the skip parameter specifies, skip every third time skip, like skip 3 time steps, then output, skip another 3. And so you can get sort of, if you have a variable time step, you can get in your simulation, you can get every other time step or every 5th time step in your output. Or you can specify that I want the time output every X number of years. And then even if you have variable length time steps, once it crosses the threshold of that output frequency, then it'll output time step. So it won't add in a time step right at the time that you requested, but the next time step it has output, once it's reached that threshold, it'll output the time step. So say you said, I want output every 10 years, but you're doing a time step every like 3 years. Once it's got 9 years, it won't output, but then once it goes to 12, it'll say, well, it's been, you want output every 10 years, it's been 12 years since I last output, so I'll output at this time step. And the timestamp for the output will appear in either the ParaView file in the file name, or in the HDF5, there'll actually be an array with the timestamps from the output. Other questions? In the VTK files, what does the double column represent? The specified parameters, displacement, strain, stress are listed. I'm not quite sure what you mean by the double column. Do you mean in the VTK files themselves? So in the VTK file, so let's look at a VTK file. So let me go back to my terminal. So let's look at the output from step 01. So this is the VTK file. So first it outputs the coordinates of the points. So there's 245 points. They're double precision. So there's 3 values, X, Y, Z. Then I have cells. I have 144 cells, a total number of entries of 1,296. That first column indicates the number of points in the cell, and then the vertices in the cell. So all of these are hex 8 cells, so they all have 8 in the first column, and then the 8 vertices. Oops. You scroll up the cell types. So for every single cell, it lists the cell types. So if I have 4 vertices in a cell, I don't know whether it's a quadrilateral or a tetrahedral cell. So ParaView asks about the cell type. So I think, yes, I think the double is referring to the precision. So here's my point data. I have 245 points. I'm going to be in vectors, so that's the 3 components. The name of the field is displacement. So I have 3 floating point values for every single point. And so that was it for that field. And so state variables will have cell data as well, but no point data. Any other questions? Okay, well, thanks for participating in this session, and we'll reconvene in about 1 hour and 45 minutes for session 2, and Charles will discuss 2D and 3D meshing strategies, and we'll make sure to record from the beginning of that session so we don't lose that. Thankfully, we have last night's recorded session along with most of this session. And feel free to work through some of these examples between now and then, as well as later today and tomorrow. And you can come back You can, as soon as you have questions, you can come back, enter them into the Q&A panel. You can send your emails to CIG-short. We'll do our best to respond to them. Between sessions within a day, there's not a lot of time, but one of the reasons why we scheduled Monday, Wednesday, Friday was so that to give people an opportunity to work examples in between the sessions. So thanks for participating, and we'll see you in a bit.